Hi, this is Ali Siddiqui, and I'm here to show you my 4-bit carry look-ahead adder that I built in Minecraft. The purpose of this design is to create a system that adds two 4-bit numbers and uses a process called carry look-ahead, in which you create a generate and a propagate. So that way you can guess which number is going to create a carry bit, and then simplify the addition operation rather than going sequentially or serially one bit at a time. So to show you how I designed it here, I'll include the gate level schematic in my lab report, but here I used only a few materials, and that was regular blocks, some levers right here, and then redstone torches and redstone dust. And basically what I did is use a combination of ore and NOTs and exclusive OR gates. And ORs function quite simply, which is just connecting two wires here, kind of like at this point. And ANDs are a little bit more complex, but still simple, in which the inputs are inverted, and then the output is inverted with a torch as well. And that wire output is right there. And then NOTs are pretty simple. It's just the output has a torch in front of it that acts as an inverter. And then the final thing was an inclusive OR, which I include right here. And then here you can see my most significant bit for each input, so A3 and B3. And then down here I have A2 and B2. As you go further down the line, I have A1, B1, A0, and B0. And then over here I have my CN input. And so I'll run through just a couple of test cases real quick to show that it works. And here's the first one. I'll input the value of 3 for my A input, and then I'll input a value of 4 for my B input. And what that should give me on my output lights, which are down here, is a value of 7. So here for my sum, I have my carry out for my most significant bit of my sum, and then I have S3, S2, S1, and S0. And as you can see right here, the value is 7. And then I'll slide over and do a couple more test cases. Real quick, I'll try adding 3 and 1 to show that my carry can propagate through multiple bits. So my A is still 3, and then I'll drop B down 1 real quick. Now that should give me an output of 4, which as you see, that's my C out. Then that's 4. And then I'll do a couple more. I'll try doing A is 7, and then B is 0. And what I'll do is I'll have my CN set to 1, just to make sure that that works as well. A is 7, all the switches for A are turned on, and then B is 0, and then I'll switch my CN to 1. That should give me a sum of just my most significant bit, which is 8. So that works. And then I'll try one last case where I have my CN set to 0, and then I'll set both my A and B to a value of 8. So all my lower bits will be set to 0. And then I'll have a 1 for each of my most significant bits. That should give me the same thing. There you go. And that right there is my 4-bit carry look-ahead adder. Thank you.